Hi, my name is Thibaut Gauthier, and I want to show you a proof my program called TacticToe discovered on its own the other day. So, about 1 week ago, I was presenting a lecture on how to teach TacticToe how to prove by learning from human proofs. As I ended the demo, a friend of mine named Bob asked me to test it on the following summation formula. I was pretty sure it would fail, but I gave it a try anyway, and surprisingly, it came up with the following proof. The proof here consists of a series of calls to different tactics. Each of these tactics performs one step of the proof. Without the knowledge of what each tactic does, the proof cannot be understood. So today I will try to analyze what is happening in these different steps for you. One can already know that this proof contains two inductions, here and here. The first step is to apply induction on our conjecture. So this is our conjecture. So now we have to prove a base case and an inductive case. This is the base case, and this is the inductive case. We obtain the base case by replacing n by 0. On the inductive case, we need to prove that if the property holds for n, it holds for n plus 1. The base case is proven by computing the value of each side of the equality. The tactic SRW solves the the right-hand side. This tactic probably knows that x times 0 is 0. The second step uses the theorem sum1, which states that to sum a value from 0 to 0, it's enough to know the value of x at 0, which is 0. So both left-hand side and right-hand side equal to 0, so the base case is proven. Okay, this starts to get a bit messier. To solve the inductive case, TacticToe chooses to do another induction. In a similar way as for the previous induction, we get the base case by replacing n by 0, and the inductive case by assuming that if the property holds for n, it holds for n plus 1. But this property is already an implication, so the inductive case becomes slightly long. Here, the base case is solved by the combination of three different things. First, the assumption is used. The assumption is the left side of the implication. It can be noticed by the use of ASM here. Second, basic arith knowledge about addition and multiplication is given by the simplification set arith SS. And third, SumDevCompute tells you how to compute a sum bounded by 1 using the value bounded by 0. So you can compute this sum using this one. This was for the base case of the second induction. Now let's do the inductive case of the second induction. This inductive case is quite large, so we still use the assumption, which is an implication. We also do arithmetic simplification, and finally we transform this summation into a use of fold left fold left is some operation about list that actually enables you to do some recursive computation on lists. So basically we have transformed a problem about summation into a problem about lists. And somehow TacticToe finds it easier to solve, which I don't. The last step of the proof is to transform this count list into snark. So that's the first thing it does. And then use a theorem that relates fold left and snark. So basically operation on list and again some arithmetic computation. The last step was, so I think this inductive case is hardest to prove, but you can try to prove it by yourself. If you do so, I recommend you not to transform the summation problem into a problem about list as TacticToe did. That's all for today. Bye bye.